In today's lesson, we're going to learn how to find the LCM of a group of numbers using the division method. Remember, multiple of any number is the number that we get by multiplying our number with any whole number. So if our number is 5 and I multiply 5 with any whole number, the resultant is the multiple of 5. So for example, if I have 2, 4, 6, and 8, what is the least common multiple? The traditional method is we list the multiples of 2, 2, 4, 6, and 8. We list the multiples of 4, 4, 8, 12, 16. We list the multiples of 6, 6, 12, 18, 24, 8, we would say 8, 16, 24, 32. We'd have to keep going, but as you can see, once we list all the multiples, we have to find the one that's the lowest and common between all four of them. Instead of doing that, we can use the division method. Now, using the division method requires you to follow certain rules. The first rule is that when dividing, you cannot have a remainder. The second rule is you have to divide at least two numbers in every step. Rule number 3, it does not matter which numbers you divide first as long as you're dividing at least two numbers in every step. Multiply all the numbers on the outer ring. Now, if these rules don't make a lot of sense, watch the next couple of examples and it will become clear. Now, when I start the division, I can start with 2 and I divide 2 by 2, I get 1. Divide 4 by 2 and I divide this, and this is what I get. Now, 2 happen to divide all four of them. Now I get to the next step, I see I have 1, 2, 3, and 4. Now the second rule, which is probably the most important rule, states you have to divide at least two numbers in every step. Can you think of one number that would divide at least two of these numbers without a remainder? Oh, and by the way, we don't really count 1. 1 is negligible. It doesn't get counted while doing this calculation. So if you said 2, you would be correct because 2 can divide 2 and 2 can also divide 4. Now once I reach this step, notice since we don't count 1, we just leave them alone, but there isn't any number that can divide 3 and 2 without leaving a remainder. So I cannot find one number to divide at least two numbers, and that indicates to me that the division step is done. Finally, it says multiply all the numbers on the outer ring. What do I mean by this outer ring is this. Alright, so the numbers that I divided by and whatever is left on the bottom. If I multiply these, that will give me my LCM. So 2 times 2, 4, 4 times 1, 4, 4 times 1, 4, 4 times 3, 12, 12 times 2 is 24. And the LCM of 2, 4, 6, and 8 is 24. Let's try another example. Let's try to find the LCM of 5, 10, 20, and 36. So let's start our division process. Remember, as long as I can divide at least two of the numbers, I can go ahead and start my division. So I can divide 5 by 5, I get 1. Divide 10 by 5, I get 2. I divide 20 by 5, I get 4. 36 cannot be divided, so I just leave it as it is and bring it down. Now in this step, I see that I have 2, 4, and 36. They're all divisible by 2. So I do that. Remember, ones don't get counted. Now in the next step, I can still divide two numbers, meaning I can divide 2 by 2, I get 1, and I divide 18 by 2, and I get 9. Once I reach this stage, I should realize that there isn't two numbers that I can divide, so this makes my outer ring, and I need to multiply everything that's on this outer ring. 5 times 2, 10, 10 times 2, 20, 20 times 1, 20 times 1, 20 times 1 is just 20, and finally 20 times 9 is 180. So the LCM is 180. Now the same number, I could have divided slightly different, and I would have still gotten the same answer. Instead of dividing by 5 like we did here, let's start dividing by 2. So I can't divide 5, so that stays there. I can divide 10. I get a 5 here, I get a 10 here, and I get 18. In the following step, I can now say, well, let's divide by 5. If I do that, I get a 1, I get a 1, 2, 18. And in this step, let's divide by 2. 1 and 1 stay there. 2 divided by 1 is 1. 19 divided by 2 is 18 divided by 2 is 9. And notice that I cannot go any further, which means that's the end, and I have to take the numbers in the bottom and the numbers on the side, which forms this outer ring, and I multiply them. 2 times 5, 10, 10 times 2, 20, 20 times 1 is 20, finally 20 times 9 is 180. And I get the same response, same answer, regardless of what number I start dividing by, as long as I am following these 4 rules. Let's try another example of finding the LCM, and this time let's find the least common multiple of these numbers: 5, 20, 48, and 60. These numbers are large numbers, and their least common multiple is also going to be huge. And doing this problem the traditional way of listing all the multiples and then picking out the smallest one that's common would be extremely time consuming. So let's start off our division. Remember, as long as I can divide 2 of the numbers, I can go ahead and divide. So I'm going to start dividing by 5. So I can do that here. I get a 4 here. Can't divide 48, so that just gets pulled to the bottom. Can't divide 60, and I get 12. Now here, I can divide by 2 because that will divide 4, 48, and 12, but I notice that 48 times 4 is 12. So the question is, can I divide by 12? Yes, I can, because if I divide by 12, I get a 4 here, and I get a 1 here. And notice that I'm still following my rule, which is be able to divide at least 2 of the numbers in every step. Once I reach here, it becomes pretty self-evident that I can divide by 4, and once I have all 1s in the bottom, remember we don't count 1, so that's the end of my division. So I have to take all the numbers in my outer ring and multiply it. 5 times 12 is 60, 60 times 4 is 2,400, and obviously if I multiply them with 1 times 1 times 1, I would still get 2,400. Let's find the LCM of 12, 20, 50, and 75. Again, I start with the division. Remember, as long as I can divide 2 of the numbers, I am able to move forward. So I'm going to say let's start dividing by 5. 12 comes down because I can't divide 12 by 5. Remember, we cannot have any remainder. I could divide 20 by 5. I get 4. 50 divided by 5 is 10. 75 divided by 5 is 15. Once I reach this step, I have many ways I can start. I can divide by 2, and I can divide 12, 4, and 10, or I can divide by 5. So let's keep up the trend. Let's keep dividing by 12. If I do that, I can divide 10, I get a 2 here, 15, and I get a 3 here. Notice, as long as I'm able to divide any 2 numbers, I can move forward and do it. The moment I can't is where my steps stop, and now I have to find the outer ring. So here I can say, well, let's start dividing by 2. I get a 6 here, I get a 2 here, and I get a 1 here. Because I was able to divide 3 numbers, I am still in the clear, and I keep going forward. Here, I divide by 3. So one number can divide 2, so that comes down in another number. And in the final step, we're going to divide by 2. And notice how I have all 1s in the bottom. So we don't divide the 1s, we don't really count the 1s, and here is my outer ring. Now in my outer ring, once I have these numbers, what do I need to do? I need to find the product. So 5 times 5, 25. 25 times 2, 50. 50 times 3, 150. 150 times 2 is 300. Now if I multiply them with 1 times 1 times 1 times 1, I'm still going to get 300 as the LCM of these 4 numbers.